Hello friends, welcome to Bindu Dhadwal chemistry lessons. The topic for today is compounds of group 15 elements, and the compound that we'll be covering today is nitric acid and dinitrogen. So nitric acid, the major process for manufacture of nitric acid is by Ostwald process. The process is carried out in various steps. The first step is catalytic oxidation of ammonia with atmospheric oxygen. For this, ammonia is fed into chamber and oxidized with oxygen in presence of platinum or rhodium gauge catalyst at a temperature of 500 Kelvin and 9 bar pressure. The ammonia gets oxidized into nitric oxide and the reaction is an exothermic reaction. The heat generated in the reaction is sufficient to carry out the reaction once the reaction is initiated. After nitric oxide is formed, the second step involves combination of nitric oxide with oxygen. So air is passed and nitric oxide is oxidized to nitrogen dioxide. Then nitrogen dioxide is dissolved in water to form nitric acid, which is 68% by mass, and along with it nitric oxide is formed. The nitric oxide thus formed is recycled and aqueous nitric acid can be obtained. It can be obtained and used in laboratory as such. In case if it is to be used in higher concentrations, then it can be concentrated by distilling up to about 68% by mass, and later on this can be further concentrated by dehydration with concentrated sulfuric acid to get about 98% pure nitric acid. This process is called dehydration. In the laboratory, nitric acid is prepared by heating with potassium nitrate or sodium nitrate with concentrated sulfuric acid. Sodium nitrate plus sulfuric acid will form nitric acid plus sodium hydrogen sulfate. Nitric acid's property, it is a colorless liquid with boiling point 355.6 Kelvin and freezing point 231.4 Kelvin. It has a planar geometry with oxygen-nitrogen-oxygen bond angle 130 degree and hydrogen-oxygen-nitrogen bond angle 102 degrees. There is a one nitrogen-oxygen double bond and one coordinate bond extended from nitrogen towards oxygen, and the bond lengths are as given. Chemical properties. Nitric acid is a strong acid and a strong oxidizing agent. It can oxidize all sorts of metals that are more electropositive than hydrogen, less electropositive than hydrogen, even noble metals. So less reactive metals like copper, they give different products with different concentration of nitric acid. For example, with dilute nitric acid, nitric oxide is formed, whereas with concentrated nitric acid, nitrogen dioxide is formed. More active metals with dilute nitric acid will give nitrous oxide, whereas with concentrated they will give nitrogen dioxide. A very prominent test that is conducted to detect nitrate ions is called brown ring test. To the aqueous solution of nitrate, freshly prepared ferrous sulfate solution is added, and to it concentrated sulfuric acid is added carefully along the sides of the test tube. A brown ring is formed at the junction of the two liquids, indicating the presence of nitrate ions. So the ferrous ions will convert the nitrate ions into nitric oxide, which will be taken by hydrated ferric to form penta aqua nitrosyl iron complex, which is of brown color. The presence of brown ring indicates the presence of nitrate ion. Uses of nitric acid. It is used to manufacture ammonium nitrate for fertilizers. It is also used in explosives. The recent bomb blast that took place in Beirut involved the ammonium nitrate explosive. It is also used to prepare other explosives like nitroglycerine, nitrocellulose, and some other compounds. Nitric acid is used in pickling, that is cleaning of stainless steel utensils and objects, and it is also used for etching of metals. The next compound that we will be covering is dinitrogen. It was discovered by Daniel Rutherford in 1772. The methods of preparation: in the laboratory, it is prepared by heating in an aqueous solution containing ammonium chloride and sodium nitrite. By heating, nitrogen, water, and sodium chloride is formed. Another method is by thermal decomposition of ammonium dichromate, in which ammonium dichromate is heated to give chromic oxide, nitrogen, and water. By thermal decomposition of sodium of barium azide, nitrogen gas can be obtained. NaN3 on heating at 573 Kelvin forms sodium and nitrogen gas. Similarly, barium nitride also gives nitrogen gas. This reaction is important. Thermal decomposition of sodium azide is used to inflate the airbags used for safety devices in some cars. Properties of nitrogen. Nitrogen is a colorless, odorless, and tasteless gas. It's chemically unreactive at room temperature because the nitrogen-nitrogen bond in nitrogen is a triple bond with bond length of 109.8 picometer, very small bond length, and bond dissociation enthalpy 941.4 kilojoules per mole, because of which it cannot react. Now, nitrogen is found to react with metals forming metal nitrides. For example, lithium plus nitrogen forms lithium nitride. With dioxygen at a temperature above 2000 Kelvin or in presence of lightning, nitrogen is oxidized into nitric oxide. This also forms the main reaction in the Birkeland and Ide method for preparation of nitric acid. With calcium carbide, nitrogen reacts at 1300 Kelvin to form a mixture of calcium cyanamide and carbon, which collectively is used as a fertilizer under the name nitrolim. So uses: dinitrogen is used in the manufacture of compounds like ammonia, nitric acid, calcium cyanamide, etc. It is used in providing inert atmosphere in iron and steel industries.